Torch index add. Description. The torch index add function performs an in-place addition operation on a tensor along a specified dimension, using the values from another tensor and a set of indices. Inputs. Input 1 input tensor, the tensor on which the addition will be performed. Input 2 index tensor, a long tensor containing the indices of the elements to be added to. Input 3 source tensor, the tensor containing the values to be added. Outputs. Output 1 input tensor, the modified input tensor with the added values. Steps. Step 1 for each element in index. The function retrieves the corresponding element from source. Step 2, the retrieved element from source is added to the element in input at the index specified by the corresponding element in index. Challenges and fixes. Challenge 1 index should be a 1D tensor containing valid indices within the specified dimension of input. Sample use case that resulted in challenge 1 index contains indices outside the bounds of a dimension of input. Fixes to challenge 1 ensure that index contains valid indices within the specified dimension of input. Challenge 2 source should have the same number of elements as index. Sample use case that resulted in challenge 2, the length of source does not match the length of index. Fixes to challenge 2 ensure that source has the same number of elements as index. Challenge 3 source and input should have the same data type. Sample use case that resulted in challenge 3 source and input have different data types. Fixes to challenge 3 ensure that source and input have the same data type. Torch tensor index add. Description. Input 1 a tensor called input of arbitrary shape. Input 2 a tensor called index of size n, which is an index of the input tensor. Input 3 a tensor called source of size n, where matches the size of input. Output 1 a tensor called output, which has the same size and shape as input. Step 1 input tensor input is taken, and the elements corresponding to the indices in index are added with the corresponding elements of the source tensor. Step 2 the output tensor output is returned. Challenge 1 the size of index should be n, and the size of source should be n, where matches the size of the input tensor. If the size of the index tensor is different from n, then it will throw an error. Make sure the size of the index tensor is n, and the size of the source tensor is n, where matches the size of the input tensor. Challenge 2 the indices in the index tensor should be valid indices of the input tensor. If the index tensor contains invalid indices, then it will throw an error. Make sure the indices in the index tensor are valid indices of the input tensor. Torch index copy. Description. The torch index copy function modifies a tensor by copying the elements from a source tensor to specific indices within the destination tensor. It offers a way to selectively update elements based on their positions, without modifying the original source tensor. Inputs. Self tensor, the destination tensor where elements will be copied. Dim int, the dimension along which the indexing is performed. Index tensor, a tensor containing the indices along dim where the source tensor's elements will be copied. The index tensor must have the same size as the source tensor along dim. Source tensor, the source tensor containing the elements to be copied. Outputs. Self tensor, the modified destination tensor, with elements from the source tensor copied to the specified indices. Steps. Determine the indices specified by index along the dim dimension in the destination tensor. Retrieve elements from the source tensor based on the corresponding positions in the index tensor. Copy these elements from the source tensor into the specified indices within the destination tensor. Challenges and fixes. Challenge 1: mismatched dimensions. Sample use case that resulted in challenge 1 trying to copy elements from a source tensor with a different dimension than the destination tensor's DIM specified. Fixes ensure that the size of the index tensor matches the size of the source tensor along DIM. Adjust the dimensions of the tensors or the indexing strategy to maintain consistency. Challenge 2: out-of-bounds indices. Sample use case that resulted in challenge 2 providing indices in index that exceed the valid range for the dimension DIM in the destination tensor. Fixes verify that the indices specified in index are within the valid bounds of the DIM dimension. In the destination tensor, adjust the index tensor to ensure that all indices are within the valid range. Challenge 3: inconsistent data types. Sample use case that resulted in challenge 2 trying to copy elements from a source tensor with a different data type than the destination tensor. Fixes ensure that both the source tensor and destination tensor have the same data type. If necessary, convert one of the tensors to match the other's data type. Torch index reduce. Description: the torch index reduce function performs a reduction operation on a tensor along a specified dimension, using a set of indices to select elements for the reduction. Inputs: input the input tensor to be reduced. Indices: a tensor containing indices used for selecting elements from the input tensor. DIM: the dimension along which the reduction is performed. Reduce the reduction operation to perform. This can be one of the following: sum of the selected elements, mean of the selected elements, minimum of the selected elements, maximum of the selected elements. Includes ELF: whether to include the element itself in the reduction. If false, default. Only the elements at the specified indices are used. If true, the element at the current index is also included. D-type: the desired data type of the output. Outputs: output the reduced tensor. The shape of the output tensor is the same as the shape of the input tensor except for the dimension along which the reduction is performed. Steps: the torch index reduce function first selects elements from the input tensor based on the specified indices. The selected elements are then reduced according to the specified reduce operation. Challenges and fixes. Challenge 1: incorrect indices. If the indices provided are out of bounds, the function will raise an error. Sample use case that resulted in challenge 1: Python. Input tensor torch, array 12, reshape 3, 4. Indices torch, tensor 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Output torch, index reduce input tensor. Indices, DIM 1, reducism. Fixes to challenge 1 ensure that the indices are within the bounds of the input tensor. Challenge 2: unclear reduction operation. The reduce argument can be one of several operations. Specifying the wrong operation will result in incorrect output. Sample use case that resulted in challenge 2: Python. Input tensor torch, array 12, reshape 3, 4. Indices torch, tensor 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Output torch, index reduce input tensor. Indices, DIM 1, reduce product. Fixes to challenge 2 specify the correct reduction operation from the available options sum, mean, min, max. Torch tensor index reduce. Description: the index reduce function in PTorch performs a reduction operation over a tensor along specific indices. It calculates the sum of elements in a tensor. but only for the elements specified by the provided indices. Input 1 input, this is the tensor on which the reduction operation will be performed. Input 2 indices, this is a tensor of indices that specify the elements to be included in A. Reduction. Input 3 dim, the dimension along which to perform the reduction. Input 4 reduce, the reduction operation to be performed. This can be sum or max. Input 5 includes ELF, Boolean. Whether to include the index itself in the reduction. Input 6 dtype, optional the desired data type of returned tensor. Output 1 output, the resulting reduced tensor. This tensor will have the same number of dimensions as the original tensor, but with the specified dimension reduced according to the provided indices. Step 1 The index reduce function first identifies the elements in the input tensor that correspond to the indices provided in the indices tensor. Step 2 The specified reduction operation e.g. sum is applied to these selected elements. Step 3 The result of the reduction is stored in the corresponding position in the output tensor. Challenge 1 Attempting to reduce along a dimension that is larger than the number of dimensions in the input tensor. Let's say you have a 2D tensor and attempt to reduce along dim 3, which is invalid as the tensor only has 2 dimensions. Ensure that the specified dim is within the valid range of dimensions for the input tensor. Challenge 2 Providing indices that are outside the bounds of the input tensor. If you provide indices that are larger than the size of the corresponding dimension in the input tensor, you will encounter an error. Carefully validate the indices to ensure they are within the valid range for the input tensor. Challenge 3 Providing indices with invalid data type. Sample use case that resulted in challenge 3 If you provide indices that are not of integral type, you will encounter an error. Fixes to challenge 3 ensure that the indices are of integral type, such as long tensor. Challenge 4 Using an invalid reduction operation. Sample use case that resulted in challenge 4 Trying to use index reduce with a reduction operation other than sum or max would result in an error. Fixes to challenge 4 Make sure to use either sum or max for the reduce argument. Torch. Index select. Description. The torch index select function is used to select elements from a tensor based on a given index tensor. It allows you to extract specific rows or columns or higher dimensional slices from the input tensor. Inputs. Input 1 input This is the tensor from which you want to select elements. It can be of any dimension. Input 2 dim This is the dimension along which you want to perform the selection. For example, if you have a 2D tensor, dim 0 selects rows, and dim 1 selects columns. Input 3 index This is a tensor containing the indices of the elements you want to select. The size of this tensor must match the size of the input tensor along the specified dim. The elements of index must be within the valid range of indices for the input tensor. Outputs. Output 1 output This is the selected tensor containing the elements corresponding to the indices specified in the index tensor. The output tensor has the same shape as the input tensor, except for the dim dimension, which has the same size as the index tensor. Steps. Step 1 The index select function iterates over the elements of the index tensor. Step 2 For each index, it retrieves the corresponding element from the input tensor along the specified dim. Step 3 These selected elements are then assembled into the output tensor. Challenges and fixes. Challenge 1 Invalid indices Providing indices outside the valid range for the input tensor will result in an error. Sample use case that resulted in challenge 1. Python. Input torch, tensor 1, 2, 3, 4, 5, 6. Index torch, tensor 2. 3. Output torch, index select input. 1. Index error, index out of bounds. Fixes to challenge 1. Ensure the indices in the index tensor are within the valid range of indices for the input tensor along the specified dim. Challenge 2. Mismatched dimensions. The index tensor size must match the size of the input tensor along the specified dim. Sample use case that resulted in challenge 2. Python. Input torch, tensor 1, 2, 3, 4, 5, 6. Index torch, tensor 0, 1. Output torch, index select input. 0. Index error, mismatched sizes. Fixes to challenge 2. Make sure the index tensor has the same size as the input tensor along the specified dim. Torch masked select. Description. This function is used to select elements from a tensor based on a given mask. The mask is a Boolean tensor that specifies which elements to select. Inputs. Input 1 tensor, the input tensor from which to select elements. The data type of the tensor can be any of the supported data types. Input 2 mask, the Boolean tensor that specifies which elements to select. The mask tensor should have the same shape as the input tensor or be broadcastable to the input tensor. Outputs. Output 1 A1D tensor containing the selected elements from the input tensor. The order of the elements in the output tensor is the same as the order of the true values in A. Mask tensor. Output 2 none. Steps. Step 1. The function iterates over the input tensor and the mask tensor element by element. Step 2. For each element in the input tensor, if the corresponding element in the mask tensor is true, then the element from the input tensor is selected and added to the output tensor. Otherwise, the element is skipped. Challenges and fixes. Challenge 1. The shape of the mask tensor does not match the shape of the input tensor and cannot be broadcasted to the input tensor. Sample use case that resulted in challenge 1 when the mask tensor has a different shape than the input tensor and cannot be broadcasted to the input tensor. A runtime error will occur. Fixes to challenge 1. The shape of the mask tensor should be the same as the shape of the input tensor or be broadcastable to the input tensor. You can use the torch broadcast shapes function to check if the shapes are broadcastable. Challenge 2. The mask tensor is not a Boolean tensor. Sample use case that resulted in challenge 2. If the mask tensor is not a Boolean tensor, then the function will not be able to correctly identify which elements to select. Fixes to challenge 2. The mask tensor should be a Boolean tensor. You can convert a non-Boolean tensor to a Boolean tensor using the torch bool function. Torch moveDOM. Description. The torch moveDOM function in PTorch is a powerful tool for manipulating the dimensions of tensors. It allows you to rearrange the dimensions of a tensor by specifying the source and destination indices. This is particularly useful when you need to perform operations that require a specific dimension. Ordering, like broadcasting or applying convolutions. Inputs. Input 1 tensor, the input tensor whose dimensions you want to rearrange. This can be any multi-dimensional PTorch tensor. Input 2 source, a list or tuple of integers specifying the original positions of the dimensions you want to move. Input 3 destination, a list or tuple of integers specifying the new positions of the dimensions. After the rearrangement, the length of source and destination should be the same. Outputs. Output 1 tensor, the rearranged tensor with the dimensions moved according to the specified source and destination indices. The shape of the output tensor will be altered based on the dimension movement. Steps. Step 1. Determine the original dimensions of the input tensor. Step 2. Specify the source and destination indices. The source indices indicate the original positions of the dimensions you want to move, and the destination indices indicate the new positions. Step 3. Apply torch, moved in tensor, source, destination to rearrange the dimensions of the tensor. Challenges and fixes. Challenge 1. Incorrect dimension indices, providing incorrect or out of bounds indices for source and destination can lead to errors. Sample use case that resulted in challenge 1. Attempting to move a dimension beyond the existing dimensions of the tensor. Fixes to challenge 1. Ensure that the source and destination indices are valid and within the range of the tensor's dimensions. Double-check the tensor's shape in the intended dimension movement. Challenge 2. Mismatched source and destination lengths. If the lengths of source and destination are not equal, torch, movedom will raise an error. Sample use case that resulted in challenge 2. Attempting to move two dimensions but providing different lengths for source and destination. Fixes to challenge 2. Ensure that the lengths of source and destination are identical, reflecting the number of dimensions you want to move. Correctly specify the intended source and destination indices for the dimensions you want to rearrange. Challenge 3. Confusing dimension order. The order of dimensions can be tricky to understand, especially with higher dimensional tensors. Sample use case that resulted in challenge 3. Attempting to move dimensions without fully understanding the original and desired dimension order, leading to unexpected results. Fixes to challenge 3. Visualize the tensor's shape and dimensions before applying torch, movedom. Carefully consider the original and desired order of the dimensions. Use a debugger or print statements to track the shape of the tensor after applying torch, movedom. Challenge 4. Inconsistent dimension rearrangements. Multiple calls to torch, movedom can lead to unexpected results if the dimension movement is not consistent across all calls. Sample use case that resulted in challenge 4. Calling torch, movedom with different source and destination indices in separate operations, potentially resulting in conflicting dimension rearrangements. Fixes to challenge 4. Plan the overall dimension movement strategy in advance. Apply torch, movedom with consistent source and destination indices throughout your code. Consider using alternative methods like torch, permute for more complex dimension rearrangements. Torch, move axis. Description. The moveAxis function in ptorch is used to rearrange the dimensions of a tensor by moving specific axes to new positions. It allows for flexible manipulation of tensor shapes, particularly when dealing with multidimensional data. Inputs. Input 1 tensor, a ptorch tensor whose axes you want to rearrange. Input 2 source, an integer or a sequence of integers representing the original positions of a axes you want to move. Input 3 destination, an integer or a sequence of integers representing the new positions for a specified axes. Outputs. Output 1 tensor, a new tensor with the same data as the input tensor but with the specified axes moved to the designated positions. Steps. Step 1. Identify the axes you want to move. You specify the source positions of the axes you want to rearrange using the source argument. Step 2. Define the target positions. Use the destination argument to indicate the new positions you want to assign to the chosen axes. Step 3. Move the axes. ptorch moveAxis function handles the actual rearranging of the tensor dimensions, placing the specified axes at their new positions. Challenges and fixes. Challenge 1. Incorrect source or destination indices. If you provide incorrect or out of bounds indices for source or destination, The function will raise an error. Sample use case that resulted in challenge 1 moving axis 3 to position 5 in a tensor with only 4 dimensions. Fixes to challenge 1 ensure that the source and destination indices are within the valid range of your tensor's dimensions. Challenge 2 overlapping source or destination indices if you attempt to move an axis to a position that's already occupied by another axis, or if you try to move multiple axes to the same position. The function might result in unexpected behavior. Sample use case that resulted in challenge 2 moving axes 1 and 2 to position 0. Fixes to challenge 2 make sure that the destination indices are unique and do not overlap. If you need to move multiple axes, ensure that their target positions are distinct. Challenge 3 dimensionality mismatch if the lengths of source and destination do not match. You will encounter an error. Sample use case that resulted in challenge 3 specifying a single source index but multiple destination indices. Fixes to challenge 3 ensure that the number of source axes and the number of destination positions are equal. Challenge 4 understanding axis reordering while move axis makes it easy to move specific axes. It's important to understand how this operation affects the overall structure of the tensor. Sample use case that resulted in challenge 4 unexpected tensor shape after multiple move axis calls. Fixes to challenge 4 visualize the tensor's shape before and after each move axis operation to understand the changes in the layout of your data.